So now we'll be talking about different types of data and choosing the right graph. So we can either have qualitative or quantitative data. This is descriptive. It's things like favourite colour. Non-numerical. It's non-numerical. But quantitative, it is numerical. And qualitative data is always discrete and ungrouped. Ungrouped means not split up into numerical intervals. And because qualitative data doesn't even have numbers in it, can't be split up into numerical intervals, so it cannot be grouped. And it's always discrete because can't take a range of values, only clear-cut categories. So, for example, your favourite colour, it's never going to be some thing like, not like your height where it could be 156.888 or something like that. It can only be, it could be red, it could be blue, it could be purple, which is red and blue, it can only be a specific thing. But then for quantitative, can be numerical, but it can be discrete, or it can be continuous. Discrete means it's can only take a finite amount of values, number of values, infinite, but for continuous it's an infinite number of values within a range. And that's the thing with colour. There's only a finite number of colours, so it is going to be discrete data. And so for qualitative, different presentations. You could have a pictogram, you could have a bar chart, pie chart, a sectional bar chart, or a vertical line graph. And so for pictogram, the advantage is it's visually appealing. And this is sort of like things where you could say people's favourite hobby, and then you do an image of a tennis ball, and then for however many people, you draw that number of tennis balls, and then you do maybe a PS4 control to show the number of people who like gaming. And so here it could tell you 2 people like, and this could be, and then you could have a key means 10 means 10. So you interviewed 50 people, 30 said tennis, and 20 said gaming. Could be what that means. And for a bar chart, it emphasises the number in each category. And you know that a bar chart looks like this. And you want it to be 2D, not 3D, because 3D is misleading, because you can actually make it look like it's more by making it 3D, so people don't know to look from the front or the back, and so that can be used to manipulate the data presentation. And now a pie chart, rather than emphasising like the number in each category, it emphasises the proportion of the whole sample, because this is what a pie chart really looks like. And so it might want to show this one has by far it's got about nearly half of the whole sample. Now sectional bar chart kind of does the same thing, but it does both of these things actually, because it will kind of look like this. And then you'd have a scale on here with numbers, so it could be like 10, 20, 30, 40. And then for a vertical line graph, it could be, if we go back to favourite colours, and it said Jan, Feb, March, you could do a dot here to say, well, let's just make this 10, 5 and 15. And then it could show change over time. Etc. And you could also then join them together. And to make a proper line chart. And this is what we call time series data. It actually measures and counts stuff over time. And once again, that can be misleading. For example, if you did golf score, if you say you went 100, then you put the bottom as 95, and then you did that. But then you actually imagine that, say, compared to 72, which is roughly par, it would actually look like a much smaller change. So this is misleading. So those are the different advantages of those qualitative presentations. For quantitative, there are a few we can use. If we're looking at discrete data for a small grouped amount, and for ungrouped, just use this, use one of these if it's ungrouped. But if it's a small grouped amount, then you'd use a stem and leaf plot. And the advantage of the stem and leaf plot, you can see the shape quite easily. And then, well, for a large grouped amount, now this technically, histograms and cumulative frequency graphs should only be used for continuous data, but if you have a large grouped amount, it can be very difficult to do a stem and leaf plot. So you kind of cheat a bit, and you could use a histogram or a cumulative frequency graph. And for histogram, you want to emphasize shape or modal class. But for cumulative frequency graph, it's better for things like percentiles. And the further calculations are simpler. And so, based on this information, you should be able to judge what representation is appropriate and answer questions on in the exam if they ask you, okay, well, this guy's used this graph, why might this one not be the best? And what would you say is better and for what reason? And for continuous, use histogram or cumulative frequency.